Yeah. In this class, I would like to teach you uh, continuation of reflection of light. In the previous class, we have studied that image formation by concave mirrors. In this class, I'm going to discuss image formation by convex mirror. Convex mirror. Okay. Yeah. So yeah. Here in this class, here I'm going to discuss. I want to teach you that concave. So image formation by concave mirrors. So for example, you know that here what is a concave mirror? This is my bulge surface should be reflecting surface, halo surface should be silver coated. So halo surface should be silver coated, silver coated. Okay, and indicate the pole of the spherical mirror, that is a convex mirror. This is a P. And where is the center of curvature? That should be always right side of the this mirror. That is because if you complete this entire circle, the sphere, and we get the center of curvature here. This is the center of curvature C. If you join pole and center of curvature, we get a principal axis. This line is called as a principal axis. Principal axis. Now, again, in this case also, so we need to change the position of the object, then find out what is the corresponding image. For example, the first case, the case number one, the object is at a object. First case, object object is at infinity. Is at infinity. Now, in this case, again, whatever the cases we have taken, the concave mirror, same cases we'll take in this case also. Okay. Now, object is in infinity. So, if you take already, I said that whenever the object is at infinity, all rays are parallel to each other. So, these are the rays which are coming from the object, which are parallel to the principal axis, which are parallel to the principal axis. Okay. Yes. One more I can take here. These also rays which are parallel to the principal axis, and these rays are coming from the object which is at infinity. Okay. We know that one of the rule, that is a image formation rule in case of a convex mirror. The rays which are parallel to principal axis after reflection, they appears to meet at a focus. So this is all reflected rays. They are diverge, but our eyes always feel that their all rays are coming from this focus. So they're all meeting at a, if you back trace it here, they're meeting at this point. They're meeting at this point. And this point is called as a pole, and also image that is found at a focus. Okay. So what is the nature of the image? First here, when the object is at infinity, definitely what is image? Image information. So we need to write image information. What is the size of the image? Size of the image is a the size of the image is a diminished image. Diminished image, or highly diminished. So highly diminished. Okay, this is point size. Point size means very diminished size. Okay, and what about the nature? Nature means here whether it is real or virtual image. It is definitely virtual image, because here all reflected rays, they are not meeting on point. So they are appears to meet. That is called as a virtual image. Every virtual image is a rect image. A rect image. Okay, these are 2 points we need to understand here. In the case of convex mirror, the second case. What is second case here? Now place the object. Now I can take a you move the object is moved towards the mirror. So first take a convex mirror. This is a convex mirror, and this is my principal axis. This principal axis of a convex mirror. This is the pole. This is a center of curvature. This is center of curvature. Okay. Yes. Now in this case, so there is object at this point here. The height of the object is A and P. That is the height of the object is H. Okay. Now, first of all, we should form the image of this A part. Okay. Further, we can take minimum two rays. One is parallel to the principal axis. Parallel to principal axis. After reflection, they are diverged like that because it is a convex mirror. So this is a normal. This is a reflected ray. Okay. Right. So where is a focus? This is the focus. This is a focus. Next here. Now we can do one more ray, that is which strikes the, sorry, I want to erase it one. Yeah. So one more ray we can take from the object, that is strike the pole, and after strike the pole is reflected back symmetrically. This is a reflected ray for the second instant ray. Yeah. They are not really meet. They are, if you back trace it here, if you back trace it here, they are meeting at one point on the principal axis. That is a, so this is a meeting. We are meeting at one point. Meeting at a one point on the principal axis. So we back trace it here. So back trace it here. They're forming a, yeah. So this is a small part. Okay. And also we can take this part also because the B is put on the perpendicular. B is forming here. So A dash and B dash. Okay. So this also diminished image. This also diminished image. So compared to the previous one here, so somewhat increase the size of the image increased. So that means here wherever the place of object which is moves towards the mirror, the image always forming between the pole and focus here. That is the conclusion point here. So only we have two cases here. So what is image here? Image always form between the focus and pole. Focus and the pole and the diminished image. Diminished image. What about the nature of the image? Nature is always a virtual image because all reflected rays are not really meeting. So a virtual image. Virtual image, and erect means here the orientation of the AB, the object, and orientation B are both are same. Okay, like that. If you move the same object towards mirror, the object image also moving towards mirror. So this is a which is moving towards right side, which is moving towards left side. But size is always size of the image always less than the size of the object. This is the cases we need to remember. Okay, so I want to give the conclusion for the both cases here. For concave mirror, for concave mirror, for concave mirror, and convex mirror. So these points are very important. Conclusion is very important for every concept. So these conclusions are very important for the board examination as well as the MSET and the NEET examination. For concave mirror, so we form the real image and also virtual image. You can form both images. But to form virtual image in the case of concave, object should be in between the focus and pole. Then only we can form the virtual image. And also in this case, the size of the image is greater than the size of the object. But in the case of real and inverted, virtual and erect, Okay. But in this case here, the real image case here, so sometimes size of object is less than the size of image, and sometimes size of object is equal to size of image, and sometimes size of object greater than the size of image. So all cases are possible. Okay, na? We need to remember it's very important concave mirror. And also in case of concave mirror, the focal length always negative. So the focal length of the concave mirror always negative. and radius of curvature also always negative, always negative. So remember this one here. This point very very important while doing the problems. Okay, in case of convex mirror, always we form virtual image. Always we form virtual image and erect. In this case here, size of image, the size of image always less than the size of object. Size of image less than the size of object. So remember this point, very very important. Okay, so with real image, so that it may possible size of the object less than the size of the image, size of the object is equal. So at what position size of the object less than size of the image? At infinity and beyond center of curvature. Okay, na, beyond center of curvature and between the C and F. What about size of the image? The object is at what position of the object is equal to size of the image? So at center of curvature, if you place the object center of curvature, at that condition, size of the object should be is equal to size of the image. And if you place the object between C and F, the size of the image is greater than the size of the object. This in this case size of the object. Okay, right. This is about the informations. Okay, right. Next, go for the magnification. Before that, here we need to know mirror formula. So mirror formula is very very important. Mirror formula. Mirror formula. What is the mirror formula? So this mirror formula gives the relation between the object to distance, object to distance, object to distance, image distance, image distance, object distance and image distance, and focal length, focal length, and also radius of curvature. So we need to make the relation between the object distance and image distance, focal length, and radius of curvature. Radius of curvature. Okay. So out of this, the object distance is represented by letter U. Image distance is represented by letter V. Focal length is small f, and radius of curvature is f. So out of 4, we should know 3, and we calculate other quantity. Okay. Right. So for this, I can take one more slide. Yeah. So for this, I can take concave mirror. So this is my concave mirror. That means bulged surface should be silver coated. Silver coated, and this is a center of the mirror, spherical mirror. That is the pole, and this is so. If you take a line which join the center of curvature and the pole. So this is my center of curvature. This is my midpoint. Midpoint of center of curvature and the pole is a focus, principal focus. Okay, right. So I want to indicate the first notations here. What is the object distance? So, for example, I can place here. For example, I can place the object at beyond center of curvature. Okay, so this is my object. I want to represent point. Top point is A. Top point is top point is B. Top point is B, and bottom part, which is on the principal axis AB. Okay, there is a height of the object is AB. Okay, right. So now first check the what is the image location when you place the object beyond the center of curvature. You know that if you place the object as beyond the center of curvature, the image should be in between the center of curvature and the focus. Check it here. First, I can take one line which is parallel to the principal axis. Principal axis. After rule here, the ray which is parallel to principal axis, after reflection, it passes through the focus. This is a reflected ray. This is a reflected ray for the incident ray. Okay, right. One more I can take here. The ray which is passing through the center of curvature, and after reflection, you know that here after reflection, again it is reflected back and follow the same path. This is reflected ray. Okay, so I want to represent with different colors so that we can understand. So the reflected ray with the red color. So reflected ray for the first instant ray, and reflected ray for the second reflected ray, second instant ray. So they are meeting at this point. They are meeting at this point. This is a position of A. Let it be. This is A dash. A dash. Okay, and sorry, B dash, because we find the image location of B. That's why this is B dash. B dash. What about A? A is a put out. If I, for example, if it is point, definitely forming the image here. Okay, here they are forming the image. If you take this point and again form the image like that, so that's why A is the foot of the perpendicular for the principal axis. Definitely A also forming here. That is, I can take A dash. This is A dash and B dash and A dash. This is A dash and this is a B dash. Okay, right. So I want to take the points here. I want to take this point is a M point. Okay, and this is A, and this is A and B, and the center of curvature. So I want to, so where is the image distance here? The distance between the image and pole is called as the image distance. That is a B. Where is object distance? The distance between the object and the pole. Object and pole, that is a U. Focal length. This is a distance between the focus and the pole is called as a F. Okay. So after that, so now we need to form the relation between the image distance and object distance and focal length. Okay, right. Yeah. So here, if you see with the object distance, there is a triangle is there, and this triangle, the triangle ABC, triangle ABC, and with image, triangle A dash, B dash, B dash, and C. They are forming at a common point C. They are similar triangles. They are similar triangles. Okay, and A dash, triangle A dash, B dash, and C are similar triangles. Similar triangles. They are similar triangles because they are forming the two triangles with the same common point, and this is they are called as similar triangles. Similar triangles. Okay, right. So for similar triangles here, the put the sides, the opposite sides, the sides of the ratio of the side of one triangle should be equal to side of the other side. Okay, that means for this triangle ABC, this I can take the side AB is the one side, the ratio of AB and the to the ratio of this triangle A dash B dash. That is AB by A dash B dash. Next, what about this here? This is here. This side AC, the ratio of AC. What about second triangle? Second is A dash C, A dash C, A dash C. So this is equation number 1. Okay. Next here I can take a triangle A dash B dash with F focal length. Okay, one triangle, and also with the same focal point, one more triangle. That is for example, I want to draw the a line which touch the principal focus. I can take here P dash. Okay, you know that here this line and this line are all paraxial rays. Paraxial rays means here which are near to the principal axis. That's why I can write a P dash and P dash should be approximately equal to P. Okay, na? Because paraxial rays means here paraxial rays means here, so all rays are very close to each other. That's why this ray is near to the principal axis, so that here P dash is equal to P. That is can write a triangle FMP. Okay, so next here triangle A dash, B dash, and F, sorry, F and triangle M P dash F, triangle M P dash F. Okay, where P dash is equal to P. Okay, and also MP dash is equal to AB or not, because parallel, they are parallel, therefore AB is equal to MP dash. So AB is equal to, can I write a MP dash? Yes, MP dash. Okay, same. For similar triangles here, the ratio of the opposite side is A dash B dash should be is equal to ratio of next triangle opposite side. So this is a MP dash. So MP dash by A dash B dash is equal to, what about here? FP dash by A dash F. FP dash by A dash F. Yeah, next. What about M MP dash, that is should be equal, can I write a MP, or otherwise it should be equal to AB or not? Yes, AB. Okay, right. So here in this case here MP dash should be equal to AB or not? Yes. So write AB by A dash and B dash is equal to what about here? FP dash by A dash F. FP dash by FP dash by FP dash by A dash F. A dash F. Okay. So you know that here what is P dash? P dash is to P or not? Yes. AB. AB is equal to A dash and B dash is equal to F P and A dash F. This is the equation number 2. Yeah, from 1 and 2. From 1 and 2. From 1 and what is the 1 here? 1 is here AB by A dash B dash. So see the LHS AB by A dash B dash. What about second equation also? AB by A dash. So can I equate here both equations? Yes, we can equate. So RHS of first equation, RHS of second equation, both are equal. So AC by A dash C is equal to equation. FP by A dash F. Okay, yeah, from this here I want to write in terms of F and B and F. Okay, go back to the diagram. AC, what is AC? I can write in terms of FP dash. So AC you can write here AP minus CP. Okay, AP minus CP. Right here AC is equal to AP minus CP. Okay, next what about A dash C? A dash C, what is the A dash C? What about A dash C? A dash C is equal to PC. So PC minus, so PC minus A dash P. A dash P. So right here and right on there, A dash C is equal to CP minus total is CP minus subtract A dash P. A dash P. A dash P. A dash P. Next, what is FP? FP is a focal length. There is a F. Okay. So write letter here. Next, what about the A dash F? A dash F is equal to A dash F. A dash F. So total is uh, A dash P minus FP. A dash P minus A dash P minus A dash P minus A dash P minus FP. Okay, let's substitute all this here. That is equal to AC. What is AC here? AP minus CP by what is A dash C? CP minus A dash P is equal to what about FP? FP What about A dash F? A dash P minus FP. Okay, what is AP? AP means here it is object distance. So object distance means here always you can negative because we measure from the pole here. That's why minus U. It is this value is minus U. What about my CP? So minus CP means here CP means radius of curvature. Always negative. So minus R. Minus R. Okay. Otherwise you can no problem. Otherwise you must write all this here. AP means here U. What is CP means here? CP is nothing but here distance between center and pole is the radius of curvature. That is radius of curvature is R by CP. CP is center distance between center and pole. That is R. R. What about A dash P? A dash P means image to pole. That is V. V is equal to FP. This is focus on pole. F. F and what about A dash P? Distance between the image and the pole. That is V. V image distance. Okay. That is what is the FP focal length? F. Simplify we get the answer. Okay. So I can say once again right here U minus R by U minus R by R minus V. R minus V is equal to F by V minus F. F by V minus F. Simplify. We get the answer. Okay. You bring V minus this side here. U minus R and I multiply bring this side here. And V minus F is equal to bring R minus V this side. F into R minus V and multiply. U into V, UV. U plus into minus. Minus U into F, UF. And minus R into V. Minus VR. Minus to minus plus R into F, RF. Is equal to F into R, FR. Minus F into V, FV. Okay, you know that what is R is equal to 2 times of FR, not 2 times of F. Just substitute here. So UV minus U into F minus V into R means 1 by 2 into F. 2F plus R is 2F and F. That is next is equal to FR. FR means 2 into F. That is F square into 2 minus F into V. So 2F square 2 into F. This is F 2F square and it cancel. Next my answer is UV minus UF minus 2FB is equal to minus FB. Okay. The next. So you bring this side here. So I want to you bring total is minus values. UV is equal to plus VUF and plus 2FV and minus FE. And UV is equal to 2FV minus FE. So UF plus FP and this is the equation. So just divide on both sides with UFB. So UV by UFB is equal to UF plus FV by UFV and UV get cancelled. Then 1 by F is equal to and divide UF by UFV plus FV by UFV. So UF we cancel, FV if we get cancelled. Therefore my answer is here 1 by F is equal to 1 by V plus 1 by U. This is my mirror formula. Okay, we remember this formula very important. Okay, so especially for the board examinations, derivation is not important for the board examination, and formula is very important. So 1 by F is equal to 1 by V plus 1 by U, where F is the focal length of the mirror and V is the image distance and U is the object distance. Okay, and while calculating the problems by using this formula, we need to you need to know sign conventions. Okay, Without sign conventions, if we substitute all this focal length value and v value and u value, we never get a correct answer. That's why, so while doing problems, we need to use the sign conventions. Okay, na? Next here, magnification. Magnification. What is the magnification? Magnification means which is represented by m. That is the size. So we need to compare the size of the image with respect to the size of the object. If it is greater, size of the image is greater. So the size of the image high value compared to the object. It means that that's why they present here size of the image by size of the object. Size of the object. So we compare size of the image with respect to object. That is called as a magnification. Okay, for example, magnification is a plus 1. It is a plus 1 means here, for example, I can take here, it is a positive. Positive means here, it is image is always virtual image. Virtual image. Magnification is negative. So image is always a real image and inverted image. For example, m greater than, so m greater than 1. That is the size of the image greater than the size of the, so size of image greater than size of object. Okay, so m less than 1, and size of image less than the size of object. Okay, if m is equal to 1, size of image is equal to size of object. Size of object. Okay, these are very very important. Okay, that is here. So from that here, for example, I want to prove that in terms of velocity, object distance and image distance. For example, I can take one object here, and I want to find this image here. So I can take one ray which is incident the pole, and this is reflected back symmetrically, and center of curvature. So this is a this point. This is a I and I dash, and O and O dash. Okay. So in that case here, if you solve it this here, we get a magnification is equal to minus v by is very very important here. Magnification, that means here what is m here? Height of the image. So size of the image means, otherwise we can write here size of the image means height of the object is the height of the image. Height of the image is I by hi by height of the object. So right here m is equal to height of the image by height of the object is equal to minus image distance by object distance. For example, some problems they are giving here, find height of the image, and height of the object is given, the image distance is given, and the image object distance is given. Then use this formula. Okay, now sometimes here they're giving a magnification given and object distance given. Use the formula m is equal to minus v by u. Sometimes they give only height of the object here, then find magnification, then find the height of the image. Depends upon the problem, you can use the formulas. Okay, enter reflection of light. So we need to remember three formulas. Right. So we need to remember three formulas here. So I write on the slide. Please note down these points. Very very important for the problems. She's mirror formula very important, especially for the problems. 4 mark question will come in the examination, 10th examination. Okay, that is a 1 by f is equal to 1 by v plus 1 by u. Mirror formula. Now after magnification, m is equal to minus v by u. That should be is equal to height of the image by height of the object. Very very important. So all these cases we need to use the sign conventions. We need to use the sign conventions. Okay, this is about the reflection of light. So I want to tell you, I'm going to take that some problems based on these formulas. That problem is here written on the board. An object, an object is placed, an object is placed at a distance of, at a distance of 10 centimeters from a convex mirror, convex mirror, convex mirror of focal length 15 centimeters, 15 centimeters. Find find the position, find the position, find the position and nature of the image, nature of the image, nature of image, nature of image. Okay, for this problem we need to find out the, in the given problem, which we need to identify the which type of mirror is given. So in this case here convex mirror is given. That's why for convex mirror image nature always virtual. Yes, so we get answer here, virtual image. The nature of the image virtual and size of the image also diminished. But the position we need to find out. And position means here where is the position of the image, that is we need to find out. We need to find out that v should be positive, because here in the case of in the case of convex mirror we are measuring from pole to right side, also relax. That's why v must be positive. That's why for that I use in this case here we should write the data. So what is the object distance here at a distance of 10 centimeter? So u is equal to, u is equal to, u is equal to minus 10 or plus 10, minus 10, always 10, always negative for the both cases. From a convex mirror of focal length always positive for the convex mirror, negative for the concave mirrors. This way 15 centimeters. Now find p, position of the image means we need to find it. Use a mirror formula, 1 by f is equal to 1 by p plus 1 by u. So 1 by f means here 15, 1 by 15 is equal to 1 by, for unknown don't take a, don't use the sign conventions. For known values we can use it. So 1 by plus into 1 by u means here minus 10 centimeters. Simplify, we get the answer. It is 1 by 15, 1 by 15 is equal to 1 by b plus into minus minus by u 60 centimeters. Sorry, u is at 10 centimeters. You bring minus 1 by 10 this side, that is 1 by b is equal to 1 by 15 and plus 1 by 10. So you know LCM of this 15 10. You know 15 10 is LCM is here, that is 30. Because here how to find LCM, we know that here which is the biggest number, 15. 15 in the 10 table not possible, and take the multiples of 15. 15 to the 30, 30 balls. 30 is my LCM. 15 table 2 times, 2 into 1 2, and 10 10 3 is a 3, and 2 plus 3 is a 5 by 30. 5 by 30, that should be is equal to, so this plus into minus, minus is minus 2 minus 3. So this is 2 minus 3 means here minus 1. So 1 by v is equal to minus 1 by 30 minus, 1 minute, just I made a mistake here. So plus into minus, minus I bring plus. Okay, minus 130 means plus, plus 130, that is a 2 plus 5 5, 5 by 30. So 5 ones are 5 6 are, and 1 by v is equal to 1 by 6 and v is equal to 6 centimeters, plus 6 centimeters means here it is a virtual image and size of the image, size of the image less than the size of the objects. V is equal to 6 centimeters. What is the nature? Nature is virtual image, nature is virtual image. Okay, next here it is a size. Size means here size of the, size, you know, size of the image should be, size of the image should be less than the size of the, because it is a virtual image, size of the object, size of object. Okay, like that we can find out the problems. Okay, right. Last problem in this class. The problem is that here so I can take here a concave mirror. Okay. Find the next problem. Find the distance of image. That is, you find u value, distance of image, and when an object is placed in the central axis at 10 centimeter from the in front, 10 centimeter in front of the mirror, concave mirror. So mirror is here concave mirror. Mirror is concave mirror, and you place the object in front of the concave mirror, which is at 10 centimeters, which is at a 10 centimeters. So here, this is the distance is here 10 centimeter object we are placing here 10 centimeters, and whose radius of curvature is given. So radius of curvature r is given, that is here 8 centimeters is given. Okay, now find out the what is the distance of image. Distance of image we have to, but not object, in image we have to find out. So you know that for mirror formula 1 by f is equal to 1 by v plus 1 by u. So focal length not given, but you know r is given. You know relation between the focal and radius of curvature. The focal length is equal to half of the radius r by 2. Then 8 by 2, that is the 2 ones are 2 fours are 4 centimeters exactly. So this is a 4 centimeter. This is a focal length. This is a f 4 centimeters. Okay. So f is equal to 4 centimeters. But it is a concave mirror. We take minus. Okay, what about u? U is always negative, minus 10 centimeters. So u is equal to minus 10 centimeter, and substitute we get the v value. So 1 by f. F means here minus 4 centimeters. V that we have to find out, plus 1 by u. U is the minus 10 centimeters. So minus 1 by 4 is equal to 1 by v plus into minus 1 by 10. You bring this side here. So 1 by v is equal to 1 by 10 minus 1 by 4. LCM of 10 and 4. So 10 not possible, and 20 is not also not possible. What about next? 40 is my LCM. 40 10 fours are 4, 40, and 4 and 4 into 1 4. Okay, next minus 4 table 4 10 times 4 10 times, that is a 4 minus 10, minus 6, minus 6 by 40, and 1 by v is equal this one. I want here v is equal to minus 40 by 6. If you simplify, we get the answer minus 6.66 centimeters. Here this object image is a real image because minus we get. So this should always forming same set of the object. Okay, this is the problems we can do. Okay, in the next class I'm going to teach you refraction of light. Okay, thank you very much.